The last technique that we are covering is partition. We can see that a combination can be viewed as a partition of a set into two subsets. Remember that we choose k elements from n elements, so we partition the set into two subsets, one with k elements and the other with the remaining n minus k. We'll generalize to a partition into more than two subsets. We are going to see that later. First, we consider this example. Suppose a homework segment has 10 problems. How many ways are there for the instructor to select 3 of the problems to grade? The easy solution to this is we have 10 problems and we choose 3 of them. So this is going to be 10, choose 3. You can do this on the calculator or using the formula. It's 10 factorial, 10 minus 3 factorial times 3 factorial. And this is going to be 120. Note here that what we are doing in the exercise is we have 10 boxes, 1, 2, 3, 4, 5, 7. We have 10 boxes that are the problems, and we are selecting 3 of them. So for example, we select this for grade, this for grade, and this for grade. Or we can have different orders here, and we have actually that are 120. But if we pick 3 of them to grade, the others, the remaining 7 are not graded, right? This is for not graded. So at the end, know that if we pick 3 of them among 10, it's the same that picking just 7. Okay, because the ordering is going to be the same. The selection are going to be the same. So we have actually that the formula and choose k is equal to n choose n minus k. You can check this on your own. How many ways are there for the instructor to select 3 problems to grade for accuracy and 5 others to grade for completion? Sorry. We have that the same. We have 10 possible problems. And let's say this is accuracy. And we have this color for completion. So we are going to pick, let's say, 3 of them, these 3. And for completion, we have 1, 2, 3, 4, and 5, for example. And we have 2 of them that are not graded. So in how many ways we can do that? Well, we are having 10 numbers, 10 problems in total, and we are picking 3 of them for accuracy, right? This is for accuracy. From the 7 remaining, we are picking 5 of them for completion. And from the 2 remaining, we are selecting 2 of them, the last 2, that are not graded, right? So in how many ways we can do that? Well, we do that, we solve this combination. This is going to be 10 factorial over 10 minus 3 factorial times 3 factorial. We have 7 factorial over 5 factorial times 2 factorial, 2 factorial over 0 factorial times 2 factorial. So we have that this is cancelled out. this 10 with this 10. So at the end we have 10 factorial over 2 factorial, 3 factorial, and 5 factorial. And this is going to be 2520. So the definition is going to be this one. The number of ways to partition n objects into r distinct groups with the ith group having n sub-i objects is going to be this, and 2 and 3 and so on until the group R is n factorial over n1 factorial and 2 factorial until n r factorial. This is called the multinomial coefficient. So this formula is actually the same for than this one. Let's see this example. How many different ways are there to arrange the letters in the word banana? So if we solve the problem, we have that we have 1b, we have 3 letters A, and we have 2 N. So we can solve this using a partition, right? This is going to be from the 6 elements in total. We are picking 1b, 3a, and 2n. And this is going to be 6 factorial over 1 factorial times 3 factorial, 2 factorial. And this is 60. We can also use the other way. It's a little longer, but it's the same. From the 6 letters that we had in total, we pick 2 of them for the, let's say, for the end letter. And from the 4 remaining, we pick 3 of them for the letter A. And from the last one, we pick 1 that is going to be for the P letter. And if we solve this, we are going to see that this is 6 factorial over 4 factorial times 2 factorial multiplied by 4 factorial, 1 factorial times 3 factorial. This cancels out, and we have that this is 6 factorial, 2 factorial, 1 factorial times 3 factorial, and this is going to be the same. So here it's easy to use the partition formula directly.